Here's a look at today's lesson on simplifying fractions. The learning targets are: I can explain how two fractions are equivalent by using the giant 1, and I can write a fraction in its simplest or lowest form. Sometimes it is useful to express a fraction in lowest terms. If you write a fraction in lowest terms, you use the smallest whole numbers possible to express the fraction. Simplifying a fraction is the process of rewriting it in lowest terms. So if your work ever says simplify this fraction, it means write it in the smallest terms. So for example, this one right here says 55 over 500. But we can make that into a smaller fraction that is still equivalent. Okay? If we were to take that number and divide both of these by 5, because I know that 5 goes into 55, and I know that 5 goes into 500. If we divide those by 5, we would get 11 over 100. So in simplified terms, it would say 11 over 100. Is this written in its simplest form? Yes or no, and how do you know? So is there any number that we could divide 11 and 100 by that gets them both in a nice solid number? A factor that 11 and 100 have in common. Is this written in its, oh, here's the next one. 28 over 60. Okay, now 28 and 60 each have 2 as a factor. So this student decided that 2 was going to be the one that they were going to use to simplify. So if we divide 28 by 2, we get 14. And if we divide 60 by 2, we get 30. So is 14 over 30 written in simplest form? In other words, is there another number that we could divide 14 and 30 by to get an even smaller fraction that would be equivalent? Is there another factor that these two have in common? So is this written in its simplest form? Yes or no, and how do you know? Simplifying fractions example slide. This is just one example of how you can use the giant 1 to help you simplify your fractions. So I took 48 over 64, and I want to write that in its simplest form. So I know that 8 goes into both 48 and 64. So I use the giant 1, but instead of multiplying, I'm going to divide. So I'm going to do 48 divided by 8 and 64 divided by 8. 48 divided by 8 is 6. 64 divided by 8 is 8. So I found a common factor among 48 and 64. I plugged that in my giant 1. Whatever I use for my numerator, I also have to use for my denominator. And I got 6 over 8. However, I think I can go lower than 6 over 8 because there are common factors between 6 and 8, and one of them is, well, the one is 2. So I'm going to use my giant 1 again. 6 divided by 2 and 8 divided by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So in simplest forms, it is 3/4. So notice how I did 1, but I thought, okay, I can go smaller than that. And I found a common factor, which was 2. Remember, a factor is a number you multiply to get to that number. So 2 goes into 8 and 2 goes into 6. And I got 3/4. What you're going to do on this last slide is you're going to simplify these 3 fractions. Put them in their simplest forms. You can use paper to write it out or use the giant 1 to help you. Replace the question marks with numbers. So to do this, you want to find the greatest common factor of the numerator and denominator to put in the giant 1. So find the largest common factor between the two numbers. Divide by that number to get your simplified fraction. So for 24 over 36, what I could do is I could start thinking about factors of 24 and 36. So for 24, I can do 1, 2, 3, 4, 6, 8, and 12, and 24. Those are my factors for 24. My factors for 36 I can do 1, 2, 4. I can do 3, I'm sorry, 3, 4, 6, 9, 12, and 36. So if I look at these, 12 is in both. So maybe I want to put 12 in my giant 1. And then I would divide to see what I get as my simplest fraction. You'll do that for all 3 of these.